So this is a very interesting question and important question also. You can observe the previous papers of the GATE. So what is the ARP request packet they used to ask? Now once you know the IP as well as MAC, then from that point onwards, this computer C1 can transmit the data packets to that computer C3, we can say. So once you get a reply, then what would be the fifth step? Previously this outer ARP table, address resolution table is empty now. It is going to update now. How it is going to update? Now you understand. If you want to know the MAC address of any computer which is on the other network, so this is the procedure. Today we will discuss about the ARP protocol, means address resolution protocol. So why this protocol is very important? Like just to knowing the IP address with the help of DNS, why it is not sufficient, and why does the user requires the MAC address of the destination? For that, the power of the ARP protocol, with the help of that ARP protocol, we will be knowing about it. And how to find the MAC address practically in the network, means in the LAN. If you want to transmit the data to a destination within the LAN, how ARP is going to work. And if you are looking to transmit the data to a computer which is on the other network, how to find that MAC address with the help of a router. So regarding all these things we are going to cover now. So after understanding this, finding the MAC address, then what are the different types of attacks? You can also call ARP spoofing attack. Sometimes you can also call it as the man in the middle attack. So these things we are going to cover in this topic. Okay, fine. So basically you can see in this particular diagram, whatever I have taken, it is ARP protocol, that is the address resolution protocol which I am discussing. So these three computers are connected in a single LAN. You can call it as the bus topology. In a single LAN they have connected, and C1, computer C1, C2 and C3, the IP address are assigned. You can see 10.0.0.1. So all are having the 10 series. So basically when you say that computers are connected in the same network, their prefix should be same, network portion should be same. And these are the MAC addresses, you can say the individual MAC address of all these computers. So by default the computers, the devices will have the MAC address whenever you are going to purchase. But once they are connected in the network, explicitly IP address should be assigned. So that is how the IP address like 10.0.0.1, 10.0.0.2 to the computer 2, and computer C3 like 10.0.0.3 are assigned. So okay, now what is the role of this ARP protocol? For example, see in this particular diagram, when computer C1, which is having an IP address 10.0.0.1, want to communicate to another system in the same LAN, the same network, this computer should know the IP address of the other system, and that will be given by the local DNS server. DNS means what? Domain name server. That means whenever you want to communicate, when you should know the IP address of the destination, and that you can get from the DNS server, you can say. Now based on that logic, if the C1 want to transmit the data to C3, okay, so the point is when C1 want to transmit the data to C3, okay, so what is the target actually? You should know the source IP address and also the destination IP address whenever you transmit the data. Okay, C1 IP address is a 10.0.0.1 and destination IP will be 10.0.0.3. But that is the IP packet which is available at the network layer. So once it come down to the data link layer is going to attach the header, because frame encapsulates the packet, you can say, or we can say the lower layer is going to encapsulate the upper layer's data. So that packet will be encapsulated by the data link layer header. So in the data link layer header, what parameters here in this context we are discussing is it has to attach the source MAC address, okay, and you should know the destination MAC address. So that is the target. Since you are sending the data from this computer only, so 12.14.1a, 12.16.1b is the MAC address. So basically what happens is when this frame is encapsulating that packet, you know the source IP address, you know the destination IP address, you know the source MAC address, but what you don't know, the destination MAC address you doesn't know, because that is placed somewhere in that LAN. In this context we have taken only 3 computers. So to find out the destination MAC only, here this ARP protocol is going to work. ARP means what? Address Resolution Protocol, you can say. So from this computer, the request packet it will go. So that request packet, you can call it as a ARP request packet. So in the ARP request packet, why you require this request packet? To know the destination MAC address actually. So in the request packet, what information will be available? Source IP address, destination IP address. Since you are sending from here, you already know the source MAC address, but what you don't know is nothing but the destination MAC address. So that is how it is represented in the next slide. You can call it as a ARP request actually. So you can observe that from computer C1, source IP address 10.0.0.1, destination IP is what? 10.0.0.3. okay. So along with that particular along with that data, now this ARP request packet, okay, the ARP request packet, what does it contains? The source MAC address also has to be attached, and what is the destination MAC address? So this is a very interesting question and important question also. You can observe the previous papers of the GATE. So what is the ARP request packet they used to ask? So ARP request packet is a broadcast packet actually. That means in the destination MAC, you are going to mention FF colon, FF colon, FF colon, like that, all ones of 48 bits you are going to send, because you don't know the physical location of the destination. Here hardly we have taken 3 computers, but you might be having some 50 to 100 computers in a single LAN. So it is broadcasted with a MAC address. Okay. So how does this ARP request is broadcasted in the LAN? You can see this internal thing, it is called it as an IP address or a IP packet. To this IP packet, so this data linker header is attached. So in the data linker header, so this will be placed here. So this is the source MAC address is placed here, and the destination MAC address you doesn't know, you all know source IP and destination IP. You already know the source MAC, but what you don't know is the destination MAC address. So that's why you can see this is called broadcast MAC address. So that is going to place it here, you can say. So this is the source MAC address and this is the destination MAC address. And you can observe that destination MAC address is what here? You can observe this address is what? Broadcast. The entire packet, okay, from here to here, this entire packet, you can call it as the ARP request packet. So this is the question in one of the GATE exam. They have asked that what would be this ARP request packet. You can see from here to here, this entire thing is called ARP request packet. So what is the ARP request packet? It is broadcast actually. So once it is broadcasted, where it will go? It will go to all the stations. For example, you can see in this diagram, this request packet will go to this computer also, but he will not respond. Why? Because the destination IP is a 10.0.0.3, but here it is having IP 10.0.0.2. He will not respond its MAC address. Our target is the other system has to respond with its MAC address once IP address is what? Matching. So then that request packet will further forwarded to this computer also. Now you can see this IP is matching with this particular IP. So this system is going to give a response, and that response you can call it as a ARP reply. Okay, and it is going to respond with what? This computer MAC address is 18:20 colon 13, 14, 16 and 1A. This is going to give response actually. So that is called ARP reply. So in the ARP reply, what would be the source MAC address? It is the MAC address of this computer. What would be the destination MAC address? It is the MAC address of this C1. So this ARP reply directly it will come to this computer only because it is requested. This gives a clear idea. ARP reply is a unicast address actually. This question they have given. ARP request is a broadcast and ARP reply is a unicast. Now you see this is what already we have covered. ARP request is broadcast in the LAN. Now if you observe the next slide that is just now I have explained. See in the ARP reply this computer is giving the reply. Now it is this ARP reply is what? You can see this is unicast actually. Means it will directly go to that particular system only. See that source IP is altered because now this is transmitting a 10.0.0.3 source IP. Destination IP this computer has requested. So it is 10.0.0.1. So for that packet the data linker header is attached. So you can see the source MAC address is 18 colon 20 colon 13 14 16 1A. This is the MAC address of this computer. Means it is giving the response. To whom destination MAC is means what? Since this computer requested this destination MAC address is 12.14.1A 12.16 1B. It is giving the reply. Now this ARP reply will directly come to this computer. Now we can say that this computer C1 knows the MAC address of this particular destination. Now the actual data transmission will be forwarded to that computer actually. So this is practically is going to happen. Here a very interesting question what you can ask is, sir, once we know the IP address we can communicate? No. You are going to know the IP address of the any destination with the help of DNS protocol. But after that you have to collect the MAC address of that computer also. And how to collect that? So for what I have explained is that only. Okay, understand? So this is how you are able to get the MAC address. Now see what happens. Now once you know the IP as well as MAC, then from that point onwards this computer C1 can transmit the data packets to that computer C3 we can say. So we can say from this one ARP request packet is a unicast or broadcast? Broadcast. And ARP reply is what? Unicast. Okay, got it? Yeah. So if you want to find the MAC address of a particular computer which is on the other network, then what is the procedure? Okay, so the point is, if you are looking for the MAC address of a particular computer, if it is in the LAN that we have analyzed, how means what? ARP request packet is a broadcast, then it will go to all the stations and the concerned system is going to give a reply if that system is in the LAN. But if that system is in beyond the LAN or in the internet, then what is going to happen? It's very clear that all the computers that go and give reply, this ARP request packet whatever you have broadcasted, that will go to the interface of the router. You can also call that as the gateway of the router because no client has responded. So in that situations, how you are going to find the MAC address of a particular system which is available on the other network or in the internet with practically from step 1 to step 5 all the steps we are going to explain now. Okay, fine. So you can observe that our target is to find the MAC address of for a device on a different network. Okay, first what is step here? Determine what? So what you have to determine the IP address of the device on the different network. So tell me how you are going to get the IP address of a particular computer on the other network. Yeah, so that will be given by the domain name service. Once you have given the host name, the concerned IP address is given. Okay, so that is obviously we can get that. So what is the second statement you can see? Send the ARP request from your device network to find the MAC address corresponding to the IP address of the device on the different network. So how to get that? So now we are trying to explain. Okay, we try to explain practically like how the things are going to happen. Now see, in this diagram you can observe that my target is computer C1. You can see it is having an IP address 10.0.0.1. So this computer which is connected to this router at a interface ETH0, not only this C1, C2, C3, all the computers are connected to ETH0. We can say all these computers are having the same prefix, or simply the definition of router is it is used for connecting multiple networks. So this side I have taken one network. So the other side I have taken another network like B1, B2, B3 are the computers and they have a different prefix of 172. Okay. Now my target is in this example C1 IP address 10.0.0.1 want to transmit the data to a system, you can say 172.0.0.58. So this is the IP address of the destination, and you can also see the destination IP address is available here, which is on the other network. First of all, you can ask me a question, sir, how does the C1 knows the destination IP address which is available on the other network? So this destination IP, this client has got with the help of a domain name service once he has given the host name. Okay, but you know very well, knowing an destination IP is not sufficient. You should also know the physical location of that particular node also, and that is called the destination MAC address, and that is where the working culture of this ARP protocol is going to work. ARP means what? Address Resolution Protocol. What it has to resolve? Address. Which address? MAC address. How to resolve? When you have given IP address. That means when you have given a logical address, it is going to resolve the MAC address. So as per the knowledge already whatever you have from computer C1, a request packet will be transmitted, and that is called ARP request frame. So in the ARP request frame, what does it contains? This ARP frame is going to encapsulate the IP packet. This packet will be encapsulated with what will be encapsulated? The source MAC address is, you can say 12.14, 1A, 12, 16, 1B, and what would be the destination MAC you doesn't know, so that's what you have to find out, and that is FF:FF, like that all 48 bits once you are going to use. And that is how we say that ARP request packet is a broadcast. Then what happens? That packet will go to this computer, but you can observe that this IP is not matching, so he will not respond. This IP is not matching with the other computer, he will not respond. So when nobody is responding in this LAN for the ARP request, then that request packet will go to the interface of this router. You can see interface of this router, it will go. So that is the first step, you can say. So that is what so far I have explained, is shown diagrammatically here. You can see from computer C1, it is step 1, it is going like this. It is called ARP request frame. You can see the source IP and destination IP. This packet is encapsulated by the MAC address, source MAC, and this is the MAC address of this computer, and this is the destination MAC address, is the broadcast MAC address. So this request packet, this request frame, you can see it has gone to the interface of the router. So to make you understand things clearly, at this router, I assume that ARP cache table or ARP table, right now it is empty for the router. So what is happening here? The request packet came to the router, and it is asking, that packet is asking the router, do you know the MAC address? Do you know the MAC address of this particular computer IP? This router is telling, no, I doesn't know, because right now my cache or ARP table is empty. Okay, hope now you understand. So this is regarding the first step I have explained. So what is the next step? You can ask me. What happens is, at this interface ETH0, you got a frame. Then this router, by removing this header, which header? This data linker header he will remove. Who will remove? This router. So once it is removed, what is going to happen? This inside one is the packet. That packet will be entered into the queue of that router actually. Because the target is now this router has to find out the MAC address of this destination IP, because right now it is empty now, that is the reason. So second step I can say, removing this data linker header of this side the network. Then once you remove the data linker header, the packet will be there. So that packet will be entered into the queue. So that is the second step which I want to show in the second slide. So far we can observe that the entire thing, my target is to explain you practically actually. Okay. Now you can see the second step. See, this is the second point which I have explained. Now I am showing diagrammatically. See, right now this ARP table is empty. So this is the second step. What is second step? See, removing the data linker header by the router and entering the packet inside the router. See, inside this router the packet will be entered. You can observe the previous slide. Okay, if I remove this one, this is going to become the packet 10.0.0.1, 170.0.0.58 and the data will be there. So that is the packet. This packet is entered into the queue of the router. Okay, so that is second step. Okay, now the point is, right now this ARP cache table is emptying. Then what happens second, or the case 3, that means what is the third step? After that, what does the router it will do? This router, it is going to forward on this side. You can ask me, so the same packet will be transmitted? No, not at all. Then what it will do? This router once again while forwarding, it has to send a ARP frame. So now you tell me who is sending that particular packet, whatever you store this router. So that is the reason this router is going to attach the MAC address of that router. See, this router is having the MAC address interface, this number actually. So this is the MAC address interface of the router. So the source MAC, whatever this router is going to attach while forwarding will be the MAC address actually. Then what is the destination MAC? That is already you know, the destination MAC is a broadcast na FF colon, and that is what here you have done. So that's why the most important thing is this ARP protocol is going to work only within the LAN, because here it is worked, you don't find a solution, and once again here now it is going to work. So obviously what would be the third packet, okay, third case which you are going to discuss now? It is router sending the ARP broadcast on behalf of this computer, you can say, by attaching the source MAC of this one, because you don't know the destination MAC now. So who is finding now this router? Because initially the table is empty. So you can observe in the third case actually. So this is how the third case, see, when it is sending the third packet, you can see for the packet, these fields are attached. See, the source MAC, you can observe clearly what is source MAC address. This is the MAC address of this router of this interface. And what is the destination MAC? Because you don't know, it is FF colon like that, all ones you are attaching. This entire thing is going to become what? Frame. Once again, it is broadcasted. Now you tell me, once it is broadcasted, ARP request is broadcasted now by this router. Yeah, what is the situation? See, once it came to this router, this computer, you can see the destination IP is 0.0.58, but it is 0.0.6 mismatching. So he will not give a reply called ARP reply. It will, so I am talking about the third case actually. And the packet it will come, IP is mismatching, no reply. Now here you see it, this IP is matching. You can see it's very clear, this IP is matching. Now once it is matching, then the ARP request packet he will take, now it is going to give a response, and that response is called ARP reply. But can you tell me to whom he will give reply? Yes, absolutely. That ARP reply will be given to this router only. Why? Because here the source MAC is 32.12.13. It cannot give a reply to this one actually. So it will reply only to this router. So that is the fourth case actually. That means what? Previously this router IP MAC address table is empty. But now once you get the reply, and that is called ARP reply, which is the fourth statement which I am going to explain. So it is going to give. So who is going to give? This computer. To whom it will be given? To this router. What will be given? This computer MAC address will be given. You can see this is the fourth packet which I am trying to explain. See, so the reply packet is coming. What is that ARP reply frame? Who is sending? This computer. So what is the source IP? See, 170.0.0.58. See, that's what you can see in the source IP. You had this one. Okay, what is the destination IP is what? Because from that only you got a packet na 10.0.0.2. Here is a very interesting question. Sir, IP why it is not changed? That means end to end IP will not change actually. That is the reason. Now you can see once you get the reply. So now this computer is sending what? Its MAC address. So what is source MAC? You can see 10.13.20.14.16.1a. See, it is giving the reply. To whom is giving the reply? To this router MAC address, you can see. So once you get a reply, then what would be the fifth step? Previously this router ARP table, address registration table is empty na. It is going to update now. How it is going to update? That so and so IP is having the so and so what? Okay, MAC actually. See, so and so IP, that 172.0.0.58 is having a MAC address of 10.13.20.14.16.1a. That is going to update, okay, in this ARP table by the router. See, previously it is empty, now it is going to update. Okay, that is the fifth step. Why it is going to update? Then that from that time onwards, it will act as a cache table or a proxy, you can say. Means what is the meaning? So you don't require to follow the entire procedure. Next time when you are looking for the MAC address of the destination, then all these people will get that information at this router only. Okay, and that is the fifth one you can see. See, the table is updated. ARP table is updated. After updating, he will send it to that one. Now the computer knows the MAC address of the destination. Then it is going to forward the data. So now very interesting point is this is the table. Why does the router is having this ARP table? Next time you tell me either this one, okay, C1, C2, C3, when they want to send a data to this 170.0.058, do we require to do all these calculations? No, directly this MAC is available at this router. So this is the ARP table which you got, ARP table, you can say ARP table entry, one single row you got. Okay, not only that, remaining all computers also in the same procedure you are going to get. So now you understand, if you want to know the MAC address of any computer which is on the other network, so this is the procedure. And why it should be available at this initially the router ARP table is empty, but now it is known information, because for future references the replies will be faster. So for what I have explained, this entire thing is given in the statements. Now you can see the third statement, for example, the ARP request will be broadcasted to all devices on your local network, asking the MAC address of the device with the specified IP address on a different network. That is what we have done in the first step. Now you can force up. If the device on the different network is reachable and configured to respond to ARP request, it will reply with its MAC address. What is the meaning of it? If the router knows the MAC address of the destination, it will give a reply. That is the meaning of it. But initially doesn't know the ARP cache table is empty. Now you can fifth one, use that MAC address. That means if it knows, use the MAC address obtained from the ARP reply to establish a communication with the device on the different network. Okay, understand? So this is which I have explained, that ARP protocol, how to find the MAC address of a particular system which is on the different network or other network. Okay, got it? Yeah. So in the previous discussion, whatever we have talked about ARP protocol, how to find the MAC address of a computer if it is in the LAN, we have covered. Followed by, if you are looking for the MAC address of the destination which is available on the other network, that also we have analyzed. So we initially thought that the routing table or the ARP table at the router is empty. So like step 1, step 3, step 4 and step 5, it has found the ARP table. Okay. So with the help of that table, the router has provided the MAC address later on to the source, and then it is able to transmit the data packets. Now, so now we are going to talk about a important concept which comes under the ethical hacking, that is the ARP poisoning attack. So first of all, if any attack has to be done, you have to find out the loophole in it. Loophole, or you can also call it as a vulnerability. So in the previous discussions, whatever you have covered in the ARP, okay, for finding the MAC address locally and also for finding the MAC address of the destination, where is the vulnerability? If you can find out, then we can easily talk about this particular type of attack. You can call it as the ARP poisoning attack. So if you observe clearly, when the data packets are transmitted from end to end, the IP address will remain the same from end to end. But if you observe clearly, when you're transmitting, when you're looking for a MAC address of the destination which is on the other network, okay, there the MAC address is changing at every hop. You can see the MAC address is changing. So that is the loophole which you have to find out. So just directly learning this ARP protocol without knowing about the vulnerability, there is no meaning for learning practically actually. What is the vulnerability there means? This C1 knows the IP address, that is 172.0.058, with the help of the DNS. Okay, with the help of DNS to the C1. Then how the C1 has got the MAC address of this computer B3 means what? It has sent a ARP, okay, request packet which is broadcasted. Just I am recollecting all the statements. Then okay, C2, C3, nobody has replied because the destination IP is not matching with anyone. Then at that time, the case 2, it is taken by the router interface. Router interface has removed the data link layer header, and that packet is forwarded by the router this side. But during that time of forwarding, if you clearly observe, the source MAC has been modified by the MAC address of this router. When it is transmitted from here, the computer C1 is using the MAC address, but the same query, once this router is forwarding, this MAC address is modified as this MAC address. This gives a clear idea. Okay, in the GATE exams also they used to ask this question, that end to end we can say source IP, destination IP remains same, but MAC address is going to change at every hop. That is what we have practically seen. Now via this MAC address you put a request. At that time this here router ARP table is what? Empty. Then once it is broadcasted there, B1, B2 has not responded, but B3 has responded this MAC address, and once it is came to the router, this router has updated this table is called ARP table. That means indirectly this router is replying that to this computer with the help of this table. Whatever you are looking for this IP address, for that this MAC address is this value, so I am forwarding it. The attacker, if he can attach to this router, because the definition of a router is it is used for connecting multiple networks. So this is one interface, one network. This is one interface, another network. A router can have multiple interface. So suppose at this interface he can connect to that interface, and you can clearly understand since MAC is changing, the hacker will use its own MAC address, because hacker will use its own computer, it will have its own MAC address, and he will use that MAC address. Okay, since you can see the concept here, okay, this computer indirectly asking the MAC address of this B3. Okay, Then with the help of what? This computer knowing the IP address, okay, of that particular computer, and it is asking. Then what this hacker can do when he put a query in, okay, hacker with the help of this IP address, okay, this 172.0.0.558 is the legitimate IP address or a correct IP address of a particular computer, and he can get from the DNS also. Then this particular hacker which is going to be connected impersonate that that hacker is having this IP 172.0.0.58. Now when the ARP request came, then what happens? C2, C3, they won't respond, but once it came to the router, the hacker at that point, it will tell that that IP belongs to me and this is the IP MAC address, and he is going to give reply to that C1. So C1 is thinking that he has got the MAC address as well as IP of the B3, but truly is what happening, this hacker has given his MAC address along with that IP. So from that time onwards, this computer C1 will be communicating to the hacker, but he is in a wrong illusion that C1 is communicating to the B3. Same like that, if you observe when this B3 want to communicate to C1, the same hacker is going to provide his IP address to that the particular B3, but this hacker is going to impersonate to this B3 by giving the IP address of the to that particular B3 as well as the MAC address. Suppose if you assume that the C1 is a LI's computer and this B3 is suppose a Bob. So LIC is thinking that it is communicating to Bob, and Bob is thinking that it is communicating to LS. But truly what is going to happen here, it is here this hacker you can also call by some nickname like Trudy. So this Trudy is going to communicate with LS and same Trudy is going to communicate to the Bob. Such type of attack you can also call it as the man in the middle attack actually. So here the loophole what you find is the MAC is changing every time at every hop. So this hacker will use its MAC address and make him communicate with the by taking the legitimate IP. Okay. So such type of attack we can call it the man in the middle attack, or you can also call this as the ARP poisoning attack, because this ARP is going to work only in the networks, local networks actually. Okay. Now you see, if I try to give the visualized representation, you will have a clear idea. Now see, here what happened when initially this C1 when he is want to communicate, you can see at this interface this hacker or a malicious user is contacting. So you can clearly observe now it is maintaining the two ARP tables actually who this hacker actually. Okay. Now see, when the C1 want to communicate, the 10.0.0.1 is my IP address, 12.14.1A121618 this is my MAC address. Okay. And I want to communicate the IP address 17.0.0.58 because C1 will get that IP with the help of a DNS. Now the ARP request he will send. Then this hacker is going to intercept that ARP request packet, and this hacker is going to provide, see here I have taken one example, let the hacker MAC address is this number. So what this hacker will do, when the ARP request came, then he will not forward that to this particular B3. He himself is going to provide his MAC address, and since he has put a request now that I am looking for an IP address, see, this is a 17.0.0.58. That means hacker is impersonating to C1, okay, that B3 address belongs to him. See, this is the reply. So this hacker is going to give a reply to the C1 as that is called ARP reply, and ARP reply is unicast. Then C1 is in an illusion that he has got the MAC address of this particular B3, but the C1 has really got the MAC address of this communicating to the B3. Same thing here also you can see, when B3 really want to communicate to the C1, B3 will get the IP address of this number with the help of a DNS. Okay. But when it is providing a ARP request, you can clearly see that hacker is providing his MAC address and you can see whatever is looking for the IP with that legitimate IP he is sending. So this Bob is an illusion, or a destination is an illusion that he is communicating to the allies, but truly is communicating to a Trudy or a hacker. So this such type of attack you can call ARP poisoning attack, or you can also call it as the man in the middle attack. So if you observe the statements, you can observe that this malicious user is using his own MAC, along with that, okay, the other legitimate user's IP address he is using. So LIC is thinking he is communicating to the Bob, and Bob is thinking that he is communicating to the allies, but truly who is playing the game is this what you can say, this hacker or a malicious user. And how this attack has been possible? Because of a vulnerability or a loophole that MAC is changing at every hop, you can say, or at every layer it is changing, you can say. Or we can say that end to end source IP, destination IP remains same, but MAC is changing at every hop. So such an attack you can call ARP poisoning attack, or you can also call this is the man in the middle attack, you can say. Okay, now based on this understanding, okay, so if you observe the statements, see, the attacker sends forged ARP messages to trick the other devices on the network into associating the attacker's MAC address. Okay, that is what I have explained with the IP address of the legitimate device. See, this is what the most important. The hacker is going to use his MAC address, and somebody else user's MAC IP address it is going to use. Okay, such as here the default gateway. So what is the meaning of default gateway? You can see this entry point is called it as the default gateway. Same like this point also you can call default gateway. Second statement, you can see this can lead to traffic being redirected, okay, through the attacker's machine, allowing them to eavesdrop on the communication or launch further attacks. Because you can see that LIC is thinking that is communicating to the Bob, but that's not happening. The traffic is redirected to the hacker, you can see, or a malicious user. This ARP spoofing can be used for the man in the middle attacks, where the attacker intercepts, modifies the data passing between the two parties without their knowledge. That means if he wants, he can just snoop the network and he can observe and he can send the same data to the Bob. But if he wants, he can modify also, because he has a privilege. Okay, he has got the entire content there. Okay, that is the meaning of it. So attackers can also use this ARP spoofing to conduct denial of service attacks. So basically, what is the meaning of denial of service attack means? Suppose you see the real actual clients, whenever they want to contact to a particular server, okay, but if such type of hackers are completely holding the resources from the server is in a feeling that he has given all the resource and communicating to the legitimate users. But if those all are held by the hacker, okay, then the actual true genuine users, they can't get the service done. That means their service is denied actually. Okay, so such type of attack is called it as the denial of what? Service attack. In some other video, I'm going to explain how exactly the denial of service attack is going to happen. Okay, see, that's what causing network congestion or disrupting connectivity. So why there is a network congestion means the actual true genuine users will not get connected. The reason is all the resources of the destination servers are holded with these malicious users. Okay. Now, what should be the countermeasures we should do to avoid such type of attacks means? Basically, if you observe the OSA model, the data will start from application layer, then transport layer, then network layer by attaching the headers. So normally if you observe clearly, the source IP or destination IP will be available at the network layer header, and the source MAC and destination MAC will be available at the data link layer header. So you know very well, at the application layer, the data we can call it as a message, and transport layer segment or a datagram, in the network layer packet, and data link layer is frame. So the lower layer is always going to encapsulate the upper layer's data. So the concept behind is, if the data which is coming from the above layer, if it is encrypted, that means encryption means what? If you can convert a plain text to ciphertext. Ciphertext means what? The language or the content which is available and transmitted on the channel. If it is in the encrypted form, which is not in an understandable form, then these contents cannot be decoded. Okay, that means it is not just the data at the application layer, at the data link layer and the network layer also, if you can provide the security there, okay, in the encrypted form, then these MAC addresses and the IP address are invisible in between the network. So like that you can provide the security. Okay. For example, you see the best example, if you go for a HTTP protocol which is at the application layer, it will use port 80, but the data whatever you transmit in the HTTP, it will be in the plain form or a plain text form. But if you can convert that, use another protocol like HTTPS, it will convert the port number from 80 to 443. Not only that, the plain text will be converted into ciphertext. So to convey in a better way, in the encrypted form, the data will go. It's not the usernames and passwords. The remaining all content also will be in the encrypted form. Then such type of attacks can be avoided. Okay, so like that we can call them as the counter measures. Like that here, different to overcome this ARP poisoning, you can go for the different counter measures, you can say. Okay, so using ARP spoofing detection tools to monitor and identify suspicious ARP activity on the network. Something like we say that IDS, intrusion detection system in a LAN, you can connect to one of the port and you can find out any suspicious activity is going or not. So that is one way to overcome the counter measure, and you can remove that particular port if that such thing is going to happen. Okay. Next you can see implementing, second one, implementing static ARP entries or ARP cache validation mechanisms to prevent unauthorized changes to the ARP cache. So what is the meaning of ARP cache? Whenever a client is requesting to the any destination, okay, that MAC address is available at that router. You can call it as a proxy also. And regarding that information is also available at that source only for further request to increase the speed actually. Okay, but if you maintain the static ARP means what? Once the information is known, if it is completely maintained as static, the MAC will not be changing. If it is changing means what is the meaning? Somebody is intercepting that data. So like that, one of the countermeasure you can provide. Okay. Like the third one is what? Configuring networking devices to restrict ARP traffic or secure ARP protocol, or you can say encrypting the network traffic. So this is what just now I explained. If you can encrypt the content, the plain text into ciphertext, so on the channel whatever the content will be in a non-understandable form, then the attacker cannot easily find the destination IP, so that he can use this MAC address and he can modify it. That is not possible because finding the IP becomes difficult for the hacker if it is in the encrypted, you can say. That is one more technique. These are the countermeasures, you can say, to prevent what? Unauthorized interception and the tampering. Yeah. So finally, what is the summary if you clearly observe? Just learning ARP poisoning, you will not get any complete idea. First, you should know ARP protocol. In that, you will have a clear idea how to find the MAC address in a LAN. Then if you are looking for a destination, which is on the other network, then also how to find a MAC address with the help of the mediating router from the internet, that also you have learned. So this is the process how you have to find analyze, okay? Because after analyzing, then you will understand that in that what is the vulnerability. What is the vulnerability? End to end IP is not changing, so that is not a vulnerability. But at every hop MAC is changing, so that is the loophole. Since MAC is changing, if a hacker can connect to router either in a wired or a wireless to the interface of a router, then if he is hacker means he is using some computer, some device, so that device will be identified at that router and he will use his MAC address, okay, and he will impersonate as somebody legitimate IP address. So this is the process of learning the ARP spoofing. So if this ARP spoofing attack has to be countermeasured, the data should be encrypted. Means it's not only the application layer encryption, at different levels also if it is encrypted. Okay, for example, in place of the IP protocol, if you use IPsec protocol, okay, IP security protocol, then IP address is also not visible actually. Destination IP, if it is not visible, then how does the hacker can map his MAC address with the legitimate IP? So that is how you can provide the counter measure. So hope understand well, and this is the sequence of learning. Okay, got it? Should have a clear idea about the ARP protocol and then followed by the ARP policy. Okay, thank you.